Okay, and we are live with a decimals lesson. We are starting this week's lesson with a review of place value. Now, place value goes on and on. That's what we call these positions before and after the decimal in a number that's expressed as a decimal. And it does go on and on, much further than hundredths, and it goes on and on much further than the tens in this direction. But I'm focusing just on these four places for a reason. I don't want to get into the really big numbers too much because students who are doing decimals already know about those big whole numbers. So this is what the focus is. And I'm not going further than the hundredths with the decimals right now because we're going to be talking about money quite a bit in this lesson. And money goes to the nearest hundredth. We're all familiar with money. Money makes decimals easier to learn. Okay, so we're reviewing the place values that we use that are in these four places. And this is called the tens, this is called the ones. So the ones, of course, is the first numbers that students get used to learning when they're really young at the beginning of their math learning. We learn the ones, but then we get to bigger numbers and we get to the tens, and then of course it goes on and on to bigger numbers. But after the decimal, this is the stuff that's supposed to be new when you're learning decimals. After the decimal, to the right of the decimal, that first position is the tenths, and the second is the hundredths. And we use these a lot and they're important. One thing to notice always is the tenths is right next to the decimal, but the tens isn't. So that's just something you have to get used to. In between the tenths and the tens are the ones. The ones is right next to the decimal. The tens is one spot over. Tenths on the right side of the decimal is right next to the decimal. Once you know this and you remember it, decimals stop being very confusing. So it's a key moment in the student's learning when they realize this is how it works. Now, without erasing this, I'm going to mention money. And I'm going to use the same number. So the number, the value, $42.83, of course, is the same number that I have up here. And therefore, in this little example of money, we are using the tens position, the ones position, the tenths position, and the hundredths position. I'm quickly going to be looking at the chat every now and then in case someone asks a pertinent question, and just to make sure that everything is okay with my students. Okay, so $42.83. We need to use the tenths to show the number of dimes that I might give in the change. And we need to use the hundredths position to show where the pennies are made clear to us. That's why with money, we have to show both of these. Therefore, when you have another decimal like this one, 42.8, if it's just a number and it's not necessarily money, we would just call it 42.8. But if it's money, we'll call it 42.80. We will put that zero in. The zero is important because it tells us the hundredths, and we always round money to the nearest hundredth. So with a regular decimal, zeros at the far right of the number don't necessarily have to be written. But with money, you should always show them if it's a zero in the hundredths position, because otherwise it's not very clear to everyone when they read it how much money you have. Here's another example. I'm running out of space before I'll erase. How about this one? $3.07. Here's another zero, and it's also important because if we don't show that zero, then would it be 3.7? Would it be $3.70? The zero being there makes it clear that it's $3.07. So we're getting into the basics of decimals, and we're seeing the way they bridge over to money. In my experience, all of the students I've ever met find decimals easier to learn than fractions because we use the decimal system for money. And money is important to everyone. So the students are already familiar with money, which means they're already familiar with a lot of the rules of how the decimal system works. And that just makes it easier to get into than some other ways of expressing numbers. Fractions, well, if the student's into woodworking, carpentry, that sort of thing, if the student hangs around at Home Depot all the time, well, then the student might be very familiar with a lot of basic fractions knowledge as well. But there are a lot of people who don't have those interests. Just seems like everyone's interested in money, though. Okay, now we're going to start, I'm going to erase, and we're going to start converting between decimal and fraction. And for now, we're going to go from decimal towards fraction. Let me erase. And remember the terminology. Remember especially that 10th position and that 100th position, because it becomes important in this part of the lesson as well. This piece of chalk is nearly finished, but I will get a little bit more out of it before I discard it. Okay, how about converting this decimal 3.1 to a fraction? Now, usually the decimals lesson, the unit on decimals, happens after the fractions unit, and that is how I do it. So I always feel like I'm talking to students, and I'm near the beginning of my decimals unit. I'm talking to students who very recently have been doing a lot of work with fractions, so they know what I'm talking about. When I say, this is kind of similar to a mixed number. If we think of a mixed number, I'll just make up an example that doesn't fit this decimal, like 2 and 5/8. The mixed number has the big number, and then it has the numerator and the denominator, and that's all part of your fractions terminology. Well, the big number is something that's actually very similar. This is what I call the big number here. It's not actually written bigger than this one, but if I'm converting this decimal into a fraction, I look at this number that's to the left of the decimal, and that's going to be my big number in a mixed number fraction. And then it starts to be really fun, because this, remember, is the 10th position. And how do we use the word 10th in fractions? We use it when 10 is the denominator of our fraction. And then this 1, we have 1 in the 10th position, so it means that we have 1/10. Therefore, this number means 3 and 1/10. It translates rather easily, rather directly. So whenever you see a decimal number like this, where you have 1 digit to the left of the decimal and 1 to the right, you're able to see it in your head. You can start using the words and say, oh, okay, so that big number is a 3, so it's 3. And then the number over here is going to be my numerator. And what's the place value? Oh yeah, it's 10th. That's going to be my denominator. You can translate rather quickly. I'm going to get rid of this 2 and 5/8 example. And let's do another translation of a decimal to a fraction. 4.8. We're really just doing the same thing. I've just changed which digits we have. We have a 4 and an 8 involved this time instead of a 3 and a 1. But it's still going to be the same process, because this 8 is still in the 10th position. And therefore, this is going to be another fraction that's going to have 10 as the denominator. So you start noticing something. 10, which is kind of an interesting and easy to use number when we're learning math, it's nice to realize that you're going to use 10s quite a lot when you're doing a certain type of math, and that's what happens here. When you're converting between decimal and fraction, that's going to be the amount of tenths you have. So therefore, over here we have 8/10, and I can just put an 8 as my numerator. And then this 4, that's the big number. It's the one to the left of the decimal, so it's the big number in my mixed number. And I have the mixed number of the fraction 4 and 8/10. Now, of course, this can be simplified. I could reduce it to 4 and 4/5, but it's still correct. It is still already a correct translation between decimal and fraction. And it's very useful to realize that you can use tenths as your denominator whenever you're doing this. Now, this works this way when we only have 1 digit to the right of the decimal. Sometimes there are more, and we'll get into some examples where there are more. But first, we're going to do a few more examples that work like this, to make sure that we feel familiar enough with it to be able to do it. I'll erase. I'll write in my next decimal, and I'll let the students go ahead and convert it into a fraction right away if they feel they know how, before I get into it myself, because I'm going to stop and take a look at what's going on in the time and in the chat. Okay, so how about 6.2? It's the same process. I'll stop for a second and take a quick look at the chat and check that time. See how many minutes are left in the class that I'm doing down there. And up here I see how many minutes I've used. I've already used almost 10 minutes in this lesson, which is meant to be an hour long. But now we're just getting into it. It's the preamble is done, and we're into the real meat of this lesson. And the meat of this lesson is, can we convert this 6.2 into a fraction? And yes, of course we can. Our big number in a mixed number is going to be a 6. Our tenths, our 2 being in the tenths position tells me that I need a 10 as my denominator, and that 2 means my numerator is a 2. And yet again, I have a mixed number, which is correct, but could be reduced if I wanted to reduce the fractional part so that it's in lowest terms. But it's kind of convenient to have a 10 because of this whole translating between decimal and fraction thing. I'm going to do another one. And then we start juggling it a little bit. This is slightly different. What about 0.3? Now we know that 0.3, I should erase that, I didn't need that 0. 0.3 could also be written just 0.3. You can write the decimal and the 3, and you don't have to put a 0 there. But this number is the same as that number, and either of them can be converted into a fraction, and we're doing the same process. That 3 is in the 10th position. We're going to be using 10 as our denominator again. That 3 is the number that's in the 10th position, so our numerator is going to be a 3. And then 0. Oh, am I going to put a big 0 here? Well, I could, I guess, but I don't have to. It means that the big number in the mixed number is a 0. It means actually that this fraction is smaller than 1. And when we look at this decimal, we realize, oh, when there's a 0 there, it means that this decimal is smaller than 1. It makes sense. I'm not going to put a big 0 there. I think I have an answer. So what do you do when there's a big 0 there? Now we know. It actually can be seen as being even a little bit easier. But how about if there's a 0 in the other position? So let's do one of those. Okay, 5.0. Okay, so this is a little bit of a weird one, but that's what you do. You do some basic, straightforward ones, and then you say, what if this, what if that? So what if there's a 0 here? When I want to convert it into a fraction, well, my big number is a 5. My denominator would be a 10 because that's the 10th position, but I would have 5 and 0 tenths. Well, that's not wrong, because 5 and 0 tenths is equivalent to 5.0. It is actually the same number, but it's not the way we would normally write it. We would normally realize, oh, okay, we don't really have to show the fraction part because we have 0 tenths. So this is equal to 5. That's what happens when you have that strange little situation where there's a 0 here. And yet we can still do it. Our technique still works. Now I'm going to switch chalk. Let's see, I have another chalk holder here, so I'll just switch to that to start with. Let's see how much chalk is in it. Not very much. I am going to have to go into my chalk supply very soon in this lesson. Okay, so the tenths are extremely useful when we convert from a decimal to a fraction. But we know that decimals don't always only have one digit to the right of the decimal. We know that often they have more than one, and we are focusing a lot on the money side of things right now. So those decimals that have 2 digits to the right of the decimal, let's try some of those. I'll leave this one here for now. 8.19. Okay, now what am I going to do? What's different here? I have the 10th position, but I also have the 100th position that's being used, and that's my clue. What I'm going to do is I'm going to make a fraction where I'm going to use 100 as the denominator. Oh, okay, so that's not really very much extra to do, is it? And what's going to be my numerator? It's going to be all of this. The whole 19 part is going to become my numerator. And then, like before, this is the big number to the left of the decimal. It's the big number in my mixed number. 8 and 1900ths is a perfectly good number, and it is equivalent to 8.19. And again, we see how useful this thing about tenths and hundredths is, because tens and hundreds are easy to deal with. And of course, if we move on to decimals that have more digits, it's going to continue being that way. Whenever you have just one digit to the right of the decimal that's being used, you will say, I'm going to use 10 because it has 1 0 in it. And whenever you have 2 digits to the right of the decimal that are being used, I'm going to use 100 because it has 2 zeros in it. So the number of digits over here tells you how many zeros you need there when you're transferring between decimal and fraction. Not so hard, but let's do a few others to practice. Erase, erase, erase. Take a quick look at the time on this device and on that device. Make sure everyone's happy. Taking a look at the chat. I don't see any questions coming in, so it must mean that everyone understands. I like that. Okay. So I did 8.19. Let's do a few more that are like that before we start doing those what if type of examples. How about 7.82? Same strategy. I'm going to use 100 as my denominator because I see that I'm going to the hundredths position in this decimal. I know my place value. There are 82 hundredths, so I write 82 here. And then the big number here is a 7. To the left of the decimal is a 7, so the big number in my mixed number is going to be 7, and I have 7 and 82 hundredths. Yes, this does become very easy very quickly, I agree, but we still have to practice. We don't want to learn something and say, oh, it's easy after the first example or the third example, and then end up forgetting. So always with math, always practice a lot. How about 2.51? I have a process. I'm following the process. Which order I put the numbers, I guess, is flexible. Once I know what I'm doing, I can say, I'm going to be a bit of a show-off and say, I'm going to put the 51 as my numerator right away because I know that's what's going to end up happening. And I'm right. And then I think I'll put the 2 as the big number in my mixed number, but I need to show that fraction bar, and I have to put a denominator in. And of course, it's going to be 100 because I have a decimal that has 2 digits to the right of the decimal point. So that means I am going to the hundredths in my place value. 100 is my denominator. This fraction could be reduced, but I'm not going to because I like using 100 as a denominator. This fraction could not be reduced. And then, of course, what if they were money? Well, I could say 2 and 51 hundredths is equal to $2 and 51 cents, which means I am translating right back into decimal mode, aren't I? And putting a dollar sign for my unit of measure. And then I realize, oh, okay, well, the decimal version of the number is already really, really ready to be expressed as money. Fraction, maybe it's a little bit more of a step to take, but it's not a very big step, especially when we understand this. Let's do another one. Let's do some of the what ifs. Let's start throwing some zeros in there and see what it looks like. $1.03. Oops. It would help if I actually wrote down the 0 in my example. Okay, 1.03. I said it correctly, I just didn't write it correctly. Okay, so what do I have to do? Oh, I have a 3, there's just a 0 there. It's like it doesn't matter. Since all I have is a 3, that means I use tenths, right? No, that's not what I'm going to do. I see that that 3 is in the hundredths position, so that means I need to use 100 as the denominator in my fraction version of this number. And then 03 means 3, so I just have 3 hundredths. The big number is a 1, because the number to the left of the decimal is a 1. 1 and 3 hundredths is the answer. Having a 0 here doesn't stop me. My process still works. And then we compare that. I finally have to get new chalk. What I'll do is I'll get new chalks for both of these chalk holders at once. Come on, get out of there. Come on, there. And my chalk supply is in here. Let's get some chalk. 2. And is that showing? It's not showing on one of my camera angles, but it shows in the other one, so I'll close it. Okay. Doing this with 2 of these chalk holders at once is actually kind of awkward. Put that down. Yeah, when you only have one, it's a lot easier. Okay, we're ready. We got enough chalk for the rest of this lesson, for the rest of this video. Checking the time there, checking the chat. I'm good. What was my next example? Oh yes, we did 1.03. I think it's quite instructive to do 1.30. Not the same number. Has a lot in common, but it's not the same number. So, what am I going to do? The number to the left of the decimal is a 1, so the big number in my mixed number is going to be a 1. I need my fraction bar. Even though there's a 0 here, I have this number written showing the hundredths. So that makes me want to use 100 as my denominator. And then I have to put 30. I have to put all of this, the 30. So 1 and 30 hundredths is an answer. It is a correct answer. But of course I could also say to myself, this 1.30 could have been written as just 1.3. That extra 0 is optional. And if I wrote it this way, instead I would have said, okay, the big number in my mixed number is a 1. My denominator is only going to be a 10 because this is only showing the tenths value. And then the numerator is going to be a 3. Not a 30, a 3. And then we realize 1 3/10 is the same number as 1 30/100. So writing the 0 is unnecessary, but it's still, being there allows us to use this strategy to correctly write a fraction version of the number. And then not showing that 0 allows us to use a slightly different, but really the same strategy to correctly write the fraction version. Which one of these is better? I think this one might be considered to be a little more simplified, because it is more simplified. But better? I don't know if it's better. They're both correct, they're both good. Okay, what's my next example? Oh, I went a little crazy with these zeros. I'm going to put some more zeros in and see what happens. Okay, 0.76. Okay, we sort of dealt with this situation where the number to the left of the decimal is a 0 when we were doing the easier examples a few minutes ago. But we may as well do it again with this situation. We have a decimal that is using the hundredths position, so I want to use 100 as my denominator. And then there are 76 here, there are 76 hundredths. I have my fractional part. There's a 0 here, so I don't really have to write a big number here because it's 76 hundredths. This is less than 1. Even though it uses a 7 and a 6, and we see a 76 here, it's still less than 1 because all of these values are to the right of the decimal. There's only a 0 to the left of the decimal. This number is in between 0 and 1. And when you think of the money side of things, that makes sense because this written as money would be 76 cents, and that is less than $1. So 0.76 is less than 1. It stands to reason. Let's do another one. Zero point 0.01. Whew. Okay, there's not much to this number. A lot of zeros, there's hardly anything there, but we can still do our process. We see that this one is in the hundredths position, so we want to use 100 as our denominator. We see 01. Now I could write 01, but I could also just write 1 because that means the same thing. I don't need the big number either because there is only a 0 to the left of the decimal. So 1/100th is the fraction equivalent of this decimal. I like this. And then the money side of things. I can write this as money, and it would mean 1 cent or 1 penny, but this is still how we write it as money because when we write money, we use the decimal system. Okay. I've gotten to the end of my first page. Let's flip this page and see what comes next. I'm going to keep an eye on the chat over here and see if the students who are able to leave are choosing to stay, because that's kind of interesting. It means that they find the lesson interesting, and I personally find it interesting, so it's kind of what I expect. But on the other hand, it is optional. Let's see. Oh, we're going to start practicing a little bit of this stuff, and we did this in the last lesson I did on decimals. We're going to practice some of the which number is bigger type of thing using the less than, greater than, and equal sign symbols. So, reminder, we have this which means less than, we have this which means greater than, and we have this which means equals. People are always familiar with the equal sign first, and then we have to get used to these. And the students get really good at it. They know which is less than, which is greater than. The only problem is that people sometimes mix up the symbols. I will repeat a lesson that I have made very many times in the past. If you're not sure which is less than and which is greater than, for what works for me, because I have always done math in the English language, is that less than starts with L, and this symbol looks kind of like an L. That doesn't look like a G for greater than, but that doesn't matter. Once I realize that the one that looks like an L goes with less than, it means the other one, by process of elimination, must go with greater than. Okay, a little tiny review of that idea. Let's use them. Let's put a pair of numbers up and we'll compare them. We'll decide which symbol goes between the numbers. So I have 8.1 and 8.2. Not very different. They are not the same number, but they are awfully close. Which one is less than, which one is greater than? I know all the students realize 8.1 is less than 8.2. It's just a matter of choosing the right symbol, so I'm choosing the right symbol that I know goes with less than. 8.1 is less than 8.2, we did that. Okay, how about 3.5 and 3.50? So if we've been paying attention to our lessons in decimals lately, we're realizing, oh, okay, that 0 is kind of optional. I didn't really have to write it. And 3.5, both of these numbers are 3.5, they're equivalent. 3.50 is equal to 3.5. So therefore, I'm using the equal sign. Haha, the teacher tried to trick me, but it didn't work. Okay, let's erase. I'm going to even erase the symbols. And we'll do a couple more of these. As we get used to a new way of writing numbers, the way of writing numbers as decimals, we have to review some of these concepts and realize that we can apply the math knowledge we've already worked on to the new situation. How about 78.01 and 78.10? Huh. 0110, almost the same number, not quite. So this is in money, this would be $78.01, and this would be $78.10. Okay, so we can see which one is greater, which one is less, and 78.01 is less than 78.10. I managed to choose the correct symbol. I have to watch out because it's easy to get mixed up, and that's why we're throwing in these examples that have zeros. How about 50.1 and 50.0? So all he's really doing in this little exercise is reviewing this idea of where are the zeros and what do they mean. 50.0 means 50. I didn't really have to write the decimal or the zero, and I would have been correct to just write 50. But 50.1, no, I have to write that decimal, I have to write the 1, otherwise I'm changing the number. So 50.1 is not the same as 50.0. Which one's bigger? 50.1 is slightly larger than 50.0, so I am going to use my greater than symbol, the one that does not look like an L or a G. Okay, so that's enough of that. That was just a little mini review of the greater than and less than stuff. And now we're going to do some more conversions between decimal and fraction, but we're going to go in the other direction, from fraction to decimal. That should be interesting. Now this could be a very big lesson with an awful lot of different types of fractions that we convert to decimals, but I'm not going to go too deeply into it. I'm going to do some of the more logical translations between fraction and decimal. And take a look at my chat, and that looks fine. Okay, and check how am I doing for time? How am I doing for time? With the amount of time I had planned for this lesson, I'm pretty much right on what I had planned. I'm getting good at this. Okay, so how about if we have the fraction 1/10? 1/10. I want to convert that to a decimal. Well, interesting that I chose a 10 as my denominator. Because with some denominators, converting into a decimal is going to be long and slow. And we don't want to get into that right away. We're just starting. But with a 10, from what we experience converting between decimal to fraction, we realize how useful it is to have a 10 as the denominator in a fraction. So to convert that into decimal, the 10 as the denominator makes me think of the word tenth. In fact, I can write this as 1/10. And that tells me I'm going to have a decimal and I'm going to need a number in this 10th position. What number will it be? The numerator is the number it will be. The numerator is a 1, so this means 1/10. I'm starting to get used to this. And then, is there a big number? Is there a number to put to the left of this? There's no big number. It's not a mixed number. It's a fraction that is less than 1. 1/10 is less than 1. So therefore, I can either not put a big number here, and it's correct, and then I'm finished, or I can put a 0 there if I wish. So this can be a matter of preference. I actually kind of prefer this one because you really see what you have. But I do know that 0.1 and 0.1 are the same number. They're both correct. So anytime we have a fraction that has 10 as the denominator, the process is going to be the same. So let's do a couple more that do. We'll have 3 tenths. How are we going to convert this into a decimal? Tenth means that I need a value to the right of the decimal. I write my decimal and I'm going to be putting a number to the right of it, a digit. What digit will that be? My numerator is a 3, so it will be a 3. I have my answer. 0.3 is equal to 3 tenths, but I can also write it as 0.3 instead if I prefer. So this is rather fast and it's not very scary, is it? 9 tenths. Okay, that's just about as big as a numerator as I could put and still have a fraction that's less than 1. But it's the same process. I see tenths as my denominator, therefore I put a decimal and I am going to need to put a number just to the right of it in the tenths position, and that number is going to be a 9. And I am finished, but I can write it as 0.9 if I wish. I need to do a few more examples where I have fractions with 10 as the denominator, but I'm going to use some mixed numbers where I do have a big number, and therefore the value I have is bigger than 1. Let's do a few examples like that. How about 7 and, let me see, 7 and 7 tenths. He's fancy, he's got 2 7s in there. Okay, so it's a mixed number. I have the big number, I have the numerator, I have the denominator, and the denominator is a 10. That is useful. So since I have a 10 as a denominator, that means I have tenths, which means I need a decimal point and I need a digit to the right of it, and that digit is going to be this 7. But this time I have the big number in the mixed number, so therefore there is going to be something besides a 0 here, and it's also going to be a 7. 7.7 means the same thing as 7 and 7 tenths. The process works. Even when we have a mixed number, we're still able to do it. How about 23 and 1 tenth? I have tenths, I need to write a decimal point, I need to put a digit to the right of it. That numerator is a 1, so that digit is going to be a 1. And then over to the big number part of the mixed number is actually 2-digit big number, it's 23, which means I put 23 here. It works, the process works fine. Nothing to be scared of. How about 14 and 8 tenths? Put my decimal. The number to the right of the decimal, the digit to the right of the decimal is going to be an 8 because that is my numerator. And then I need to put 14 to the left of the decimal because the big number part of my mixed number is 14.8. Not really too difficult. I have a feeling the students don't find it very difficult. And if I look at my chat, I see that I am not seeing all sorts of confused remarks or questions. So that means the students are understanding. That is good. Okay, let's do some where we don't have 10 as the denominator though. And I think the logical next thing to try is to do some fractions where we have 100 as the denominator. Because we learned when we were going in the other direction from decimal to fraction that tens and hundreds are both extremely useful denominators when we're doing this. So how about 35 hundredths? This is less than 1 because the numerator is smaller than the denominator. So I'm not too surprised to realize that there's no big number here, so there's not going to be anything over here unless I decide to put a 0. But before I worry about that, I'm looking at my denominator and saying 100. It's 100th. It's not a tenth this time, it's 100th. That means that there are going to be 2 digits to the right of the decimal. And I have 2 digits in my numerator, so those digits are going to be a 3 and a 5. There is no big number over here, so I either just write it as 0.35 like this, or I write it as 0.35. They're both correct. Okay, not so hard. And we're not going further than that. I'm not going to the thousands because, again, I want to stick with the type of decimals that translate into money easily. And we don't go to the nearest thousandth when we're rounding money. We go to the nearest hundredth, the penny. Okay, let's do a few more examples, though. That's just the first one like this. 35 hundredths is 0.35 or 0.35. How about 26 hundredths? Same process. I'm going to write my decimal. It's hundredths, so I need to put 2 digits to the right of the decimal. I'm not going to write little markings there this time. I just realized I need 2 digits, and I happen to have 2 digits in my numerator, so therefore 26 is my numerator. That is going to be the 2 digits I need over here. This fraction is smaller than 1, so I either don't put anything here or I put a 0 there. Same number, all correct. We can do this. Okay, how about, oh, okay, he's starting to do those what if things. How about this one? 1/100th. It's still hundredth, but I have to be careful because when I put my decimal point, I need 2 digits to the right, but all I see up here is a 1 digit, this 1. So that 1 is 100th, it's not a 10th. I can't write it right here. I have to move over and write it into that second position. And this would not be a good way to finish. It is confusing. We have to put a 0 in there. So 1/100th is equal to 0.01, and it makes sense. When we go in the other direction, we're able to do that. We can do it in this direction as well. And if I wish, because this is smaller than 1, I can write a 0 to the left of the decimal if I want. Both of these are correct answers. 92 hundredths. Okay, it's back to the easier ones. This one was a little more challenging, but we're back to the ones like we had in the previous examples. I need a decimal point. I need hundredths, tells me that I have to put 2 digits here, and I have 2 digits in my numerator. They're 9 2, so I will put a 9 and a 2. I have my answer, it is correct, and I can write it with a 0 to the left of the decimal if I want. We're good. Okay. I need a little bit more practice of these what if types though. More chalk, please. 8 hundredths. There's only 1 digit in this numerator, but the denominator is 100. It's got 2 zeros. That means I need 2 digits to the right of my decimal place. Because all I have is that 8, I am going to have to put a 0 placeholder, and then I put the 8. 0.08 is equal to 8 hundredths, and if I want, I can put this 0 as well. All of these so far have been fractions less than 1. How about if you have a fraction that's greater than 1, a mixed number, but that has 100 as the denominator? So let's do a couple like that. 4 and 33 hundredths. Okay, I know what to do. I see hundredth, so I put my decimal place, and I need 2 digits, but I have 2 digits. They're both 3s, but 2 3s is still 2 digits. And then, I have this big number now. That means this fraction, of course, is bigger than 1, which means I have to put a number to the left of the decimal, and that number clearly is going to be 4. 4.33 is equal to 4 and 33 hundredths, and I don't have to talk about whether I need to put a 0 here because the 4 took that position for me. How about 5 and 70 hundredths? Interesting. It's a very similar question, but 70, let's see what happens. I see hundredths, so I put my decimal at least in space because I see I'm going to use this big number. In fact, I can do that part right away if I want. It has the big number 5 in the mixed number, so the number to the left of the decimal is a 5. I want 2 digits, so I'm going to write 70. Now, 5.70 is equal to 5.7, and I could see that that is true. This is not wrong. I sort of simplified it by just not writing that last 0. But the way it was written here made this a good strategy. It's easy to become confused. Let's do that one again and just show it differently. I'll erase these two earlier examples. 5 70/100 in our fractions bag of tricks, we know that we can simplify this. We can cancel. We can divide 70 and 100 by their common factor of 10. Or if we wish, we can cancel out a 0 from the end of both numbers. There's more than one way of doing it. So I can rewrite this as 5 7/10 if I want. And once I do that, then I change strategies because I see 10th. So I put my big number, I put my decimal, and then I only need one digit after it because this fraction has 10th as the denominator. So 5.7, I ended up with the same answer. I went about it a different way because the lack of those extra zeros when I canceled made me decide that I'm going to do the 10th strategy instead of the 100th strategy. Both of them work though. They're both correct. So this is a good what if. When you see that there's two different ways of doing it, it makes you think about what you're doing and understand it better. How am I doing for time? Let's see what's on that third page. I think I'm doing quite well for time. Okay, now the thing is, we've been sort of making this convenient for ourselves because all of our examples had 10 or 100 as the denominator in the fraction. But of course we know our fractions and we know that you don't necessarily get 10 or 100 as the denominator in a fraction very often. It might happen sometimes just by luck, but you have to be able to deal with fractions that have other denominators. So I'm not going to go into all of the different denominators, but I'll go into some of the more common ones where this process isn't too difficult, but there's maybe some extra steps involved. How about converting, give me some more chalk please, 1/2 into decimal. Now don't jump ahead because I know a lot of students would see this and say, well, I already know the answer, and they would write down the answer. That's great, but we're thinking about what we're doing. Our process, it was really helpful if the denominator was a 10 or 100, but it's not. With 1/2, the denominator is a 2, and that doesn't translate directly into the decimal system where the place values keep on being 10 times as big or 10 times as small as the place values next to them. So what should I do? Well, we know how to expand a fraction. We can expand this fraction so that it becomes a fraction that has 10 or 100 as the denominator, and I'm just going to go for 10. That'll be easier. If I multiply 1/2 by a clever form of 1, and I choose 5/5 as my clever form of 1, well, 1 times 5 is equal to 5, and 2 times 5 is equal to 10, and I know that 5/10 is an equivalent fraction. It is the expanded version of 1/2 with the denominator 10, and at that point I can switch it into decimal form very easily. I put my decimal, and I need tenths, so I need 1 unit to the right of it, 1 digit to the right of it, and that digit will be this numerator, this 5.5 or 0.5 is the correct decimal version of 1/2. Extra little step of expanding the fraction so that it had a convenient denominator. That's fun. Is it always this convenient? 2 was easy to work with as a denominator because I could convert it into 10 so easily. I can only think of one other that is as convenient. And of course, how often are you going to see, I can't play around with all sorts of different numerators because, you know, 1/2, when you have 2 as the denominator, there's not too many choices for the numerator. So I'd use 1/2. That's the one that we'll see a lot. But how about this? 1/5. Aha! If 2 can be converted into 10 easily by multiplying it by a 5, well, I guess 5 can be converted into 10 easily by multiplying it by a 2. So I multiply 1/5 by this clever form of 1, which is 2/2 or 2/2. And 1 times 2 is equal to 2, 5 times 2 is equal to 10. And guess what happened? I was able to prove that 1/5 is equal to 2/10, which I kind of already knew. But what I did was I produced a fraction that has 10 as the denominator, and it makes it easy to convert it into decimal form. I put my decimal, it's 10th, so I want 1 digit to the right of that decimal, and there's my numerator, it's a 2, that's the digit I need. And of course, if I wish, I can write it as 0.2 instead. They're both correct. So when I have a fraction with a 2 as the denominator, quickly I can get it into decimal form by doing this extra little trick. If I have a fraction with 5 as the denominator, well, there's some more variety as to what numerators you can have when 5 is your denominator, so let's do another one. How about 3/5? I'm doing the same strategy. I still want that 5 to turn into a 10, so I'm still multiplying by 2 over 2. 5 times 2 is 10, of course. 3 times 2 is 6. So therefore, I'm still able to do it. Anytime I have 5 as the denominator, I can multiply by 2 over 2, and I can create the fraction with 10 as the denominator, and then I can convert that into decimal form using the same strategy as usual. Tenth means I need one digit. There's my digit. It's a 6 this time. I don't want to use the 3, no, because that didn't have 10 as a denominator. I want to use the 6 because that has a 10 as a denominator, and this will work. And of course, I can do this as well. I'll leave that one there for a second while I erase these two. And I'll do another one with 5 as the denominator, just to prove that it can be done, that there's nothing scary about it. What if we have a mixed number where 5 is the denominator? What if we have 7 4/5? And we want to convert that into a decimal. I'm multiplying by 2 over 2. I'm not multiplying the 7 by 2 over 2. I'm just multiplying the fraction numerator-denominator part by 2 over 2. So I have to remember that my answer is going to still have that 7 there, but 4 times 2 equals 8, 5 times 2 equals 10. Now I have 7 8/10. 7 4/5 converts into 7 8/10. I have a 10 as a denominator. I know what to do. I put my decimal. I need one digit to the right of it, and that is going to be an 8. But this time it's a value, it's a fraction that's bigger than 1, so I have that big number over here, and that's the number that goes to the left of the decimal. I did it. It worked. So now we've seen a bunch of examples where we have 5 or 2 as our denominator, and we're able to convert them into something with tenths, and use our strategy that we already knew to convert it into decimal form. I will go into one other denominator though, where it's not quite as quick, because you can't get this one to turn nicely into a fraction over 10. How about 1/4? And this is as far as I'm going to push it. 1/4, a fraction with 4 as the denominator. I can't do 4 times something equals 10. That would get complicated. But wait, I can do this. Aha! I can't turn the 4 into a 10 easily, but I can still turn it into 100 easily, because 4 times 25 is equal to 100. So I use this clever form of 1, 25 25ths, or 25 over 25. And when I multiply it out, 4 times 25 is 100. That's what I was after. 1 times 25 is 25. I have 25 hundredths, and we already know how to convert that into a decimal. It's hundredths, so we're going to need 2 digits. But we have 25, we have 2 digits. We have our answer. There was no big number. It wasn't a mixed number. It's 25 hundredths is still less than 1. So this is the correct answer. But of course, I can put a 0 there if I want. And because it's a 4 as the denominator, there's a variety of numerators we can use. We can use a 2, we can use a 3. I'm going to try a 2. But I'll do the mixed number version. I'll say, 9 2/4. Quarter. Notice that. Quarter. Oh, 25 cents. Everything just seems to back me up here. Everywhere I look, I see some math that I already know that's making this all make sense to me. A quarter, 25 cents can be written like this. 1/4, 25 cents. Now, it doesn't work that way with all of the types of money in this world, but in the money in the United States and Canada, where I live, we call a 25-cent piece a quarter. Well, I guess this is the reason why. Interesting, and we see this quarter, we see 0.25, like money version of quarter, and we see these 25. It's just all, it's poetic, the way it comes together. 9 2/4. I am going to multiply it by 25 over 25. I'm not multiplying the 9 part. I don't need to, but I can't forget that it's there. So I'll write the 9. Then 4 times 25 gives me 100, which is what I wanted because I want to convert to decimal. 2 times 25 gives me 50. Oh, this could have been 5/10 if I really wanted. So I actually can branch out. I'll do like this. I can reduce this, canceling zeros, and I get 9 and 5/10. I don't think I'm happy that I put those slashes through my zeros though, because that's going to make it look confusing. So I'm going to change my mind about doing that. 9 and 50 hundredths is equivalent to 9 and 2/4, but 9 and 5/10 is also equivalent to 9 and 2/4. For this number, we can convert this into decimal in two different ways. With hundredths, I put my decimal, I need 2 digits, I have to put the 5 and the 0 therefore. And then, of course, this is the number that goes to the left of the decimal. 9.50 is equivalent to 9 and 2/4, or 9 and 2/4. But this one, I can do this with tenths as my strategy. 5/10 means I only need 1 digit to the right of the decimal, but it's going to be this 5. And I can write 9.5. I have the same answer, and these two numbers are equal. So this being able to go backwards, forwards, so many different ways, it helps us to feel like we understand. I hope that the students feel that way as well. And I'm getting close to the end of the time I have, and I wanted to do some little problems that are a little bit more chalkboard intensive. So that's the end of this page. And I can dispose of this page for now. Aha, now let's add up some money. Now last lesson, I was adding decimals. And we were trying not to make it too crazy. We added 2 decimal numbers. I never added more than 2, but I knew it was coming. And we were trying not to go to too many place values on either the left or the right of the decimal, because it was an introductory adding of decimals lesson. But now we get to try and do something that might look a little bit really big and long, but it's not so bad, because we kind of already know how to do it. And that's when we're adding money. Because if you've ever added together bits of money that you found in your pocket, then that means you've added decimals whether you realize it or not. So what I'm going to do is I'm going to draw a pile of money that might be in someone's pocket right now. So it's going to be a bunch of different coins and some bills. So I'll draw the bills first. And I'm not going to try to draw them well. I'm just going to make some $1 bills. Yes, I'll do 2 $1 bills. So this pocket happens to have 2 of those, and it has one of these, a $5 bill, and it has a $20 bill. Okay, but there are also coins in this pocket. Let's make some coins. Now I have to be careful with the sizes so that this is kind of realistic, but I won't make them really, really small because we want to be able to read them. So I'm going to make a nice big 25-cent piece, otherwise known as a quarter. And I want another one like that. So I'm going to draw another 25-cent piece. Do I have any dimes? Yes, I have 1 dime. So there's a 10-cent piece. And do I have any nickels? I have 3 of those. The nickel's slightly larger than the dime. And do I have any pennies? Yes, I do. 3 of those. So it may not be drawn perfectly, but this is actually a very realistic little pile of money that someone might have in their pocket. Now, of course, this is money from the United States. How do I know? Well, I don't know exactly all the details of how money works in every country in the world, but I have been to a few places and I've seen there's a lot of overlap in how we do things, but this is not Canadian money because we don't have $1 bills anymore. We used to. We don't have them anymore. And we don't have pennies anymore either. We used to. We don't have them anymore. So I know I must be in the United States if I find this in my pocket. Okay, let's add this together. Now this is where things get a little crazy. I know it doesn't look very hard, and I know the students probably already know the answer. That's the way the students are. But to show it in the way I was showing how to add decimals in the last lesson. Okay, I'm going to start with the biggest ones, and that's the $20 bill. And I have to write it in decimal form, which means 20.00. Even though I could just write 20, that might be confusing. Money, we show it with those 4 place values that we started this lesson with. So $20 looks like this when we write it as a decimal. And then we have a $5 bill, so that's going to look like this. And notice how we have to be careful and do the thing that we always had learned to do when we add decimals, which was we make sure the decimals keep on being right above and below each other. Otherwise it gets confusing and we make a mistake. So there's my $20 bill, my $5 bill. I need two $1 bills. And you see I'm adding together far more decimals than I ever did before, at least in last week's lesson. And I'm not even close to being finished. Look how many more there are. I hope it all fits on the video rectangle. Maybe I have to write smaller. I have these 2 quarters, which are both going to be 0.25. I only have the 1 dime, 0.10. You see how important it is, all these zeros. If we didn't write the zeros, it would be really hard to see what we have. I have 3 nickels. Is it going to fit? I'm hoping it fits. 0.05 3 times, and 3 pennies. Yes, it is going to fit. I think even the answer will fit. 0.01 3 times. It's hard for me to write this low on the chalkboard wall. And then of course we put a line and we put that plus sign to remind everyone what we're doing here is we're adding. See how that looks? Kind of hard to see it past my little tripod thing. But I think it is all fitting. We're going to be able to see what we're doing, and it looks fairly straight. Okay, now how do you add decimals? You start with this place on the far right, which happens to be our 100th place. And it's like we add numbers before we know about decimals. We're doing the same rules. 0 plus 0 plus 0. Okay, I'm adding a lot of zeros. So looking for anything that's not a 0. 5 plus 5 is 10. Plus 5 is 15. Here's another one for 20. There's another one for 25, 26, 27, 28. That was a lot to do, but it's an 8. And I carry the 2. Now I'm adding the 10th position. 2 plus 2 is 4, plus 2 is 6, plus 1 is 7. That's it. That's all the values I have that are not zeros in the 10th position. So I write a 7, and of course I need my decimal right below all the other ones. I should have put that right at the beginning. Now I'm in the ones position. And did I have to carry? No. 2, 4, 6, 7. I took the 2 I carried before, and I combined them with the others, but I didn't get a value that's higher than 9, so I don't have to carry this time. Now let's add the ones. 5, 6, 7, and that's it. So I'm putting a 7. Oh, that's really messy 7. Let's try and do it a little better. 7. And then I'm adding the tens position, but there's only one number in the whole list that has a value in the tens position, and I didn't have to carry anything, so all I have is that 2. So 27.78, don't forget the dollar sign. That is your unit of measure. $27.78 is the amount of money that we had in this pocket, which I'm sure all of the students realized far earlier than I was able to say it, but I really wanted to show all this stuff. Isn't it interesting that after adding just 2 decimals at a time in the previous lesson, now he's adding, how many of these are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 13. I added 13 decimals, and I was able to do it using the same techniques I already know. I have time to do one more example like this if I don't do it too slowly. So I'm going to erase all of this stuff that I worked so hard to put up here, and I'm going to draw some more money. I'll save some time by keeping some of these values because I'm going to use some of them again. Okay, my new little problem, I actually have 2 20s. So I'll keep this 20 and I'll put a second 20. I have 2 $10 bills. So I'm going to create 2 $10 rectangles. I only have 1 $5 bill, but I already have one here, so I can just use that. That's all the bills. Oh, I don't have any ones. I don't have any $1 bills, so that's where I need this eraser cloth. I'm going to erase these $1 bills. And I don't know why I threw that over there. I'm going to need it again. I don't have as many coins. I only have 6 coins. I have 3 quarters, so there's already 2 here. I'll take advantage of this little space to draw a 3rd quarter. And I have 3 dimes. I have a dime showing. I'll make a 2nd dime and a 3rd dime, but this time I don't have any nickels or pennies. So I will erase all of these nickels and pennies, and we have a new problem. Let's add them up. It's not 13 numbers we're adding up this time. 5, 6, 7, 8, it's 11. It's almost as many. And what's interesting about this, well, here in Canada, where I live, where we don't have pennies and we don't have $1 bills, this could still happen because there's no $1 bills or pennies in this little assortment. So this could actually happen in my pocket. Okay, let's see what I have. I'm going to add them together. We have $20. Show all the zeros, we need them, but we have two like that. And we have two $10 bills and one $5 bill. Okay, I did all of the bills. 3 quarters, 3 25-cent pieces. It's so much easier to say the word quarter, isn't it? And 3 dimes. Add them together. Show that I'm adding them together. Yes, I have room on my video rectangle. Okay, starting with the hundredths. Place value, 0, 0, 0, 0, 0, 5, 10, 15. 15. That wasn't so bad, so I need a 5. Forgot to put my decimal. I really do forget the decimal too often. I should put it in right away. Okay, right below all the other decimals, don't forget that. Now my tenths position. 0, 0, 0, 0, 0, 0, 2, 4, 6, 7, 8, 9. 9, and I didn't have to carry yet. Maybe, it looks like I might not have to carry at all to do this whole question. Now the ones position. I see all these zeros, but the 1, 5, don't miss that 5. A little bit of a messy looking 5. Finally the tens position, 2, 4, 5, 6. $65.95. I made a mistake. I have to find my mistake. 5, 10, 15. I said I wasn't carrying, but I did have to carry. I have to listen to myself. Okay, let's fix this. Yes, teachers make mistakes. Okay, I'm putting the decimal right away now. Put the 5, 5, 10, 15 means I need a 5, and I'm carrying a 1. Of course. Now, 2, 4, 6, 7, 8, 9, 10. There's more carrying than I really thought. That means I'm putting a 0, and I am carrying another 1. 5 plus that 1 is a 6. All the rest were zeros. No carrying this time. 2, 4, 5, 6. $66.05. Put the dollar sign. That is my unit of measure. I am finished. That took longer than I thought. But of course, making a mistake in the very last problem is a good way to make your video a little longer than you expected. $66.05 seems to be the answer. Correct me if I'm wrong. Thank you very much for being here with me to do this. This was fun, and I look forward to the next lesson.